Hey there, this is my presentation for the final project for data analytics. We will be reviewing the data set 5,000 um, movies by IMDb. Here you can see I imported the data and just taking a look, you can already tell that there's some nulls in there, which is going to have an impact on um, the results from looking at the data. So for the business understanding, I did some research. And after doing the research, I found that the business problem was not being able to predict the success of movies upon releasing. Um, Knowing what movies are more likely to succeed would allow for better understanding of the revenue that would come in from the movies, and then be looking at that data set. So let's take a look here. First things we're going to do is kind of see all the variables, what kind of variables are in there. We see there's a few objects, floats, some integers. We're also going to see that there's some missing data in here as well. As you can see, here's 4993, 4714. So then we're going to just take a look at a little bit of what the data looks like for each variable, for the numerical variables. And then here you can describe to see what the IMDb score is, just kind of the averages, the max, just to get a better understanding of what those look like. So data preparation here. Um, as you can see, after taking a look at all the total of the nulls, there's quite a few in here that we need to kind of get rid of. So for the gross, we're just going to take the average of the gross, and then go ahead and just replace that with all the null values. And we're going to do that same thing for budget. And we're also going to do that same thing for aspect ratio. Um, and then for the rest of these data sets, we're just going to go ahead and drop all of them. Um, and here's the rest of the data, all clean. Um, okay. So business intelligence, the business intelligence section. So I just kind of want to take a look at what are some kind of key aspects of this data. So rated R movies seem to be the most popular, PG-13 following right behind it, and PG, and then kind of so on and so forth. So we're going to take a look at what the gross revenue is for all the content ratings. You can see PG-13 is at the top, followed by rated R and PG, which if you remember from earlier that um, rated R has a lot more movies, but PG-13 is a lot more success in terms of gross. And then here's a chart representing that. Now I just want to take a look at what types of movies, like what the title of the movies are that have the most gross revenue. You can see Avengers at the top, Avatar, Jungle Book, Spider-Man 3, and then just a graph to represent that. And then for the IMDb score, here you can see Shawshank Redemption, The Godfather, Godfather Part 2, and so on. And then another graph to represent that. And then just to look at what the minimum IMDb scores the worst rated movies were. Um, and then another graph to represent that. And then what language, what country. It shows that English speaking movies seem to have a lot more success when it comes to gross revenue. And then country, United States there, and UK, which also falls into the English speaking that we saw before. And then popular actors, Johnny Depp, Robin Williams, those also can play into a factor of um, the success of a movie. And then there's just a graph to represent that. And then genre, if you remember looking back up at the most popular movies, for gross revenue, as you can see, the action is at the top of it. And if you remember correctly, the tops were mainly action movies like Avengers, Avatar, Spider-Man 3. So that gives a good idea of what that looks like. And then there's a graph to represent it. So now we're going to take a look at the correlation analysis. First, we're just going to do a simple correlation of a graph, but I think it'd be better to take a look at it from a um, chart like this. And as you can see, there's a few things that correlate, but right now we're going to look at the IMDb aspect of it. And as you can see, that duration and number of voted users have the highest highest correlation. So here's a kind of more simpler um, way to show that. And then here's a graph that represents that. As you can see that the correlation between duration and score, and then same thing for number of voted users graph. And here's just some other correlations that I found throughout the data. So cast total Facebook likes and actor one likes have the highest correlation in the data. And there's a graph to represent that. Number of voted users with gross revenue, number of voted reviews with gross revenue, and movie Facebook likes and the number of critical reviews for the movie, and a graph to represent that. And then number of users and the number of voted users. So now for the regression section of the project. Here's a regression model using all of the numerical values within the data set. As you can see, I went ahead and added all of them in there. Taking a look, there's the coefficient of y variable, but as you can see, the mean square error and the variance is not as high as more successful models, with the variance being 36%. So let's see if we can try to improve that. So now we're going to use variables that are with only a positive correlation of 0.3. As you see, they're all listed there. There's the coefficient and the y. And with not as much success um, as the variables earlier. You can see there's only a 27% variance here, and the mean is still really low. So now we're going to just use the two highest variables, which is duration and the number of voted users. Same thing again, and still pretty low. So with that said, we're just going to stick with the using all the numbers, all the variables that have numerical values. So here they are again. We're going to use it now, do a feature selection model. Um, you can see, just going to show what variables are being used. And as you can see, there's a slight, about the same percentage of variance in this model. So let's go ahead and do a random forest one, and results are much, much higher. I know the mean here looks still pretty low, but the variance is 94%, which is exactly where we want it. So now for the classification, so we'll do a decision tree classifier. It's about a 6 or 85% here, with a little, not the best results that we want. And then here's just a matrix to see that 40%, not 40%, but 40 variables that are good, are good, and then there's kind of some more information there. And now the random forest classifier, as you can see here, still much higher percentage there. You see 90%, and then select K best, which wasn't quite the results as the random forest, but still higher. So as you see, the best model is the random forest classifier. So, and then here is just a graph that shows which variables are most important when it comes to predicting the IBM score. As you see, the number of critical reviews, number of voted users, duration, which the number of voted users wasn't what we expected earlier. We expected duration to have more of an influence on that. So as you can see, doing this test definitely showed some positive results there. And then here's just the clustering, normalizing the data, adding the data to the right models, and then here's the clustering groups. And then here just a few examples of how the clustering groups are important. As you can see, gross has factors into the the variable, and so does duration, and so does budget. But if you can see here, the aspect ratio does not. It does not cross through anything. And then um, a little bit of storytelling at the end. So with that said, um, the the key models to pay attention to, as we kind of saw earlier, were um, these numerical, the number of critical reviews, number of voted users, and duration of the movie. Along with, you can factor into the successful actors in the movie, as we saw in the business intelligence, and using movies with um, English speaking that are English speaking movies also seem to have success as well. So that's my presentation. Thanks for listening. Bye.